So I want to talk to you about a topic called number systems. I find it really fascinating. I also find it really hard to get my head around. Now, the number system that we are most familiar with is the base 10 number system. Now, the base 10 number system, it pretty much comes from the fact that we have 10 fingers. Now, the 10 digits that we use in the base 10 number system are 0, 1, 2, 3, 4, 5. I think you know what I'm talking about. They're our 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And using just those symbols, we can represent any number you can think of. We can represent using those 10 symbols. So you guys are so good at this now. You've been doing it for so long that when I write the number 2397, you immediately look at that and see 2,397. And in your head, if I said, oh, there were 2,397 people there, you can imagine what that would look like. I think you should be able to imagine what that looks like. It's just become so instinctual to us. But it's important to understand what it means. This is what we would call the ones column. This is called the tens column. This is called the hundreds column. And this is called the thousands column. Pretty straightforward. So 7 ones, and you remember the little blocks from primary school, 7 ones, 9 tens, so that's 90, 300s, that's 300, and 2,000, that's 2,000. Okay, now I know it seems like I'm being really babyish around this, so let's step it up a little bit. It's called the base 10 number system. 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. Now, let's not call them the ones column, the tens column, the hundreds column, the thousands columns anymore. Let's call it the 10 to the power of 0 column. Now, anything raised to the power of 0 is equal to 1. So it's really just the ones column. 10 to the power of 1 is the tens column. 10 to the power of 2, 10 to the power of 2 is 100, so that's the hundreds column. And 10 to the power of 3 is 1,000, so that's the thousands column. Now, why have I used this notation? Because now I need to show you a different base. We can also talk in binary, which is base 2. This is the language of computers. They use base 2, which is made up of only 2 digits, zeros and ones. So while you may easily look at 2,397 and think about how many people there are, what if I instead said to you, oh, how many people were at the concert? Well, it was this many. 1, 0, 0, 1, 1, 0, 1. Now you're going to look at that and think, well, let's even put one more there. 1, 1, 0, 0, 1, 1, 0, 1. Now we need to break that down and think, what does that mean? Is that a large number of people or is that a small number of people? Now we're not dealing with ones columns and tens columns and hundreds columns and thousands columns anymore. This is the 2 to the power of 0 column. This is the 2 to the power of 1 column, the 2 to the power of 2 column, the 2 to the power of 3 column, the 2 to the power of 4, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. So each of these columns is the 2 to the power of something column. Now, 2 to the power of 0 is 1, this is 2, this is 4, this is 8, this is 16, 32, 64, 128. And I can now convert this base 2 number into a base 10 number. And I can do that by saying, okay, there's a 1 in the ones column. So that's in base 10. That's equal to 1. There's a 0 in the 2's column, so there's no 2's. There's a 1 in the 4's column, so that's 4. There's a 1 in the 8's column, so that's 8. There's a 0 in the 16th, so there's no 16th. There's a 0 in the 32. There's a 1 in the 64, so there's a 64 there. And there's a 1 in the 128. and I can add them up, 16, 20, 25, 2, that's 8, 0, 1. So if I said that there were 11001101 people in the place, there was 205 people in base 10. Now, we've looked at base 10, which you are very familiar with. We've looked at binary base 2, which is what computers talk in, I guess. But there is no limit to the bases that we can do. So I really want to take a look at one more so we can and see what that looks like.